Okay, we're learning on Theorem of Pythagoras. Theorem of Pythagoras. What is Theorem of Pythagoras? Theorem of Pythagoras, it's the formula we use to calculate, we use it to calculate, we use the formula to calculate sides of a right angled triangle. So remember, a right angled triangle looks something like this. There has to be a 90-degree angle. A 90-degree angle. So this is a right angle triangle. Remember, we did types of triangles, and then the one that we are going to use for this theorem, it's specifically the right angle triangle. So we have to first notice or identify a 90-degree angle. Now let's read it. It says, this is what it says. In any right angle triangle, can you see? I'm going to underline this part. This is the most important part. That's where we begin. In the right angle triangle, the square of the hypotenuse. What is the hypotenuse? The hypotenuse is this side. AB becomes the hypotenuse. The hypotenuse has two definitions. Hypotenuse is firstly the longest side, and secondly, it is the side that is opposite the right angle. So the side that is opposite the right angle, this side, which is this side in this case, this side becomes the hypotenuse. Are we together? This side becomes the hypotenuse. And then moving forward, this is how you get the formula. So the formula says AB squared. If we are looking for the hypotenuse, the longest side, we're going to square. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So if we want to get this answer, the value of AB squared is going to be the sum of the squares. So we're going to square the other side. AC squared and BC squared. Okay, I wrote it the other way. This is how they wrote it. Same thing. Or we can use what? We can use the letters they use, these letters. So C squared will be A squared plus B squared. So if we are looking for this, we're going to square the other two. We're going to square everything, actually. So C squared, which is the hypotenuse, will be the sum of these two sides squared. And then the other part is the formula for the other part. We get it. Very important. Say now, we're given this part. Say we are given the hypotenuse and we are asked to look maybe for AC, which is the other side, or BC. So how do you do that? We write this one, BC. We start with the one that we're looking for. We start with the one that we're looking for. So let's say we are given AC, AB, and then we're given BC, meaning what are we looking for? AC. So what will AC be? We start with AC. We're going to say AC squared will be what? Then we after writing what we're looking for, if we're given the hypotenuse, we start with the hypotenuse because we have to subtract the smallest number from the biggest number. So I'm gonna go and write the hypotenuse and minus the other side, which is what? BC, from the hypotenuse. So there you go there. Can you see even the other side? So either use these letters or you use this labeling anyhow should be fine with that. Okay, so we're gonna go straight and do questions. Okay. Okay, let's do some questions. Okay. So these are worked examples. You can pause and then try them, but we're gonna just do questions here. I'm gonna pick a few questions and then we do them. Okay. So let's start with this one. Okay. So I'm gonna start with, all right. I'm going to start with this one. So it says calculate the length of the unknown side in each of the following triangles. The triangles are not drawn to scale. Fine. But the most important thing when we're calculating this, for me to know that I'm going to apply the theorem of Pythagoras, is I have to identify the 90-degree angle. What type of a triangle is it first? It is a right angle triangle. Once I notice it is a right angle triangle, I'm going, I'm going to derive the formula. So the formula starts with what I'm looking for. I'm looking for AC. I'm looking for AC, which happens to be the hypotenuse. So if we're looking for the hypotenuse, we add. And if we're looking for the other side, we subtract based on the formulae that we saw on top there. So I'm going to say AC squared equals AB squared plus BC squared. We're together there. This is how we formulate it. And then we have to write the reason. The reason is Pythagoras. This is your reason. Always you write your reason. Then I'm going to substitute. How much is AB? AB is given us how much? 3. So 3, open bracket, square, plus. How much is BC or CB? It's given us what? 4. So in the place of BC, I'm going to put 4 and square. And then what do I do? Press this on a calculator. What is 3 squared? 9. What is 4 squared? 16. What is 9 plus 16? 25. Here I still have AC squared, AC squared, AC squared. Now here, what am I going to do? I'm going to do the square root. I'm going to do the square root. I'm going to square root both sides because the formula, it's giving me AC squared, but I'm looking for the value of what? AC. So what is square root of 25? 5. Meaning this answer here is how much? Is that fine? Okay, then we can try another one. Let's try number 6. Same thing. Number 6, what am I looking for here? I'm given this side and this side. Identify the hypotenuse. PQ, it is the hypotenuse. And then that's what I'm looking for. And then is it the right angle triangle? Yes, because of angle R is 90. So I'm going to derive the formula. PQ squared equals to what? You take the other two sides. What is this side? PR squared plus, what is this side? RQ squared. And then what is our reason, guys? Our reason is Pythagoras. Then I'm going to substitute now. In the place of PR, I'm going to put what? 48 squared plus 14 squared. PQ squared. PQ squared. Then I'm going to press that on a calculator. 48 squared will give me 2,304. And that will give me 196. Add them up together. I get 2,500 PQ. And then what are we going to do there? We're going to do square root. Don't forget, once we're here, we need to square root both sides so that we get PQ. What is the square root of 2,500? 50. So meaning this part is 50. And it makes sense. The hypotenuse must always be bigger than the other two sides. So the hypotenuse is always the longest side. So when we calculate the hypotenuse, the answer that we're expecting it has to be bigger than the two numbers there. Is that fine? Okay, okay, I'm gonna skip a few questions. This one straightforward, this one straightforward, this one straightforward. So I'm gonna do this, I'm gonna do 10 and 11, 10 and 11, whereby we are calculating the other side in this case. So let me take this up a bit. Okay, let me take it up, let me take it up. Okay, okay. Beautiful questions. Okay, erase the. Okay. Okay, let me do, which one am I doing now? 10 and 11. Then 10 and 11, we notice that it is a right angle triangle, and then we identify the hypotenuse. This is the hypotenuse. So in this case, we are not looking for the hypotenuse. We are looking for the other side. So how do we calculate the other side? This is how do we calculate the other side. We start with the side that we are looking for. AC squared equals to, now we write the hypotenuse. So I'm going to subtract this number for this side from the hypotenuse. Okay, so I'm going to have AB squared minus what? BC squared. So don't forget, if we are looking for the other side, we are always going to do what? We're always going to subtract. Is that fine? So now let's substitute. What is AB? AB is 39 squared. And then what is our BC? BC is 36 squared. Okay, then we can calculate that quickly. We got 1521 minus that. We get 1296. Then how much will that be? 225. And then AC squared will be square root both sides. And then AC will be how much? 15. 15 squared. 15, not 15 squared, 15 centimeters. It makes sense. It makes sense because we are expecting a number lower than that and lower than that, even if it's not drawn to scale. But AC has to be smaller than AB and BC. Is that fine? So I can skip this one because exactly something similar to what we're doing there. I can quickly do question 19 and question 21 or 20. Quickly, I'll do those ones and then we should wrap up the session. But nothing much. Theorem of Pythagoras. It's about calculating sides of a triangle, of a right angle triangle. And then check, are we calculating the hypotenuse? We're going to add in our formula. If we're calculating the other sides, we're going to subtract. And then don't forget to square. We're squaring each side. And then don't forget that we square the formula. And then the final answer, we need to square root to get your answer. And then don't forget to write the reason. The reason is what? Pythagoras. You get a formula for that one. Okay, let's do question 19. Then we should be moving along there, moving along quite nicely. Okay. Okay. Look at question 19. Question 19, we have two triangles there. We have two right angle triangles, and then we have the other one. We have this, it's a right angle triangle, and then there's a right angle triangle. What is the hypotenuse for this one? BD becomes the hypotenuse for this triangle. Can you see? For this triangle, that one becomes the hypotenuse. And then what is the hypotenuse for the other one? for the other one, that becomes the hypotenuse. So if you're paying attention, you'll see this is the hypotenuse for this triangle, but for this triangle, this is the other side. Do you see? And then for me to calculate the missing side, I need at least two sides. I need at least two sides. So I can see I have this is 4 and 3. So I can use these two triangles to calculate the side of this one. What am I looking for? I'm looking for C, but I'm missing a side in this triangle. I only have this side. So I need this. This is the linking side that I need to calculate for X. So I'm going to start first by calculating BD. BD happens to be the hypotenuse. Okay, let me write it here. BD squared equals to what? AB squared plus AD squared. Are we getting it? And what is our reason? Pythagoras. And then here AB is 4 plus AD is what? 3. And then 16 plus 9 is 25. BD squared, square root on both sides. BD becomes how much? 5. Is that fine? Now I'm going to go to my diagram and then I'm going to label that part as how much now? It's 5. I have 5 now. I'm going to label this as 5. Now, if I were to draw this, this is something like this now. Oh man, oh man, oh man. I have this. This is 13. This is the right angle triangle. Then it becomes the hypotenuse. I have X. Now I have 5. So this is still a right angle triangle because of this. It does not always have to be like this because other people are used to it like this. Even if it's upside down like that, as long as we can identify the right angle and the hypotenuse, we can use the theorem of Pythagoras to calculate whatever side we're looking for. So in this case, are we looking for the hypotenuse or are we looking for the other side? We're looking for the other side, yes. So how do we calculate when we're using the other side? I'm going to start with the side that I'm looking for, which is, so I'm going to write it here. DC squared equals what? BD squared plus, no, I'm wrong. I'm looking for the other side, so I need to start with the hypotenuse, BC squared minus BD squared. We together. We are subtracting in this case because we are looking for the other side. So DC, we are given the letter there, it's x squared. So I'm just going to substitute what we're given there, x squared. What is BC? BC is 13 squared minus 5 squared. So this is 169 minus 25, which is how much? That's 144. 144 x squared, square root on both sides. Then x will be how much? 12. 12 centimeters. And then our reason here is Pythagoras. Are we together, guys? I hope we're getting it. We're getting it. We're getting it. Nice, beautiful question. Two things that are linking, and then you need to see the relationship from one triangle into the other. Same here. I'm just going to tell you what to do. You can try it, and then you should comment if you need the solution or something. Here, we start with this one. We're looking for that one there, but we can't move from here to there because we have 1, 2, 3. We have 3 right angle triangles that we need to work towards, towards getting our answer there. So the first one, AB and BC, we're going to calculate what? The hypotenuse of AC. Once I have the hypotenuse of AC, I have this side is 30, and I would have calculated that one, meaning I'm going to calculate the missing side here. And then if I have this side, I have a 9 there, automatically angles on a straight line add up to how much? 180. So this will make it a 90-degree angle. And then I can just work it out from there to calculate the missing side. Is that fine? Okay, moving along. I'm not sure how much time I still have. Okay, okay. Let's move along. Let's move along. Okay, let me erase this part. Okay, now I have this beautiful worksheet. You can request it, then I can send it for you, and then you do some of these questions yourself. So this is same questions, same questions. You can do one of each, and then we can do that one also. Then we should be fine. Revision exercise. So this is exactly the same thing as what we're doing there on top. So okay, let me do that one, and then I'll do one. Yes. Okay. Where's that question? Okay, I want to do this question. This question. Let's do that question together. Now, what is saying here? We're looking for the value of x. We're looking for this part here. This part. This part. So, what do we notice now? We notice that we have a triangle. Okay, let me try. We have this right angle triangle. Firstly, did you see that? And then we have another one there. You see, we have two right angle triangles. So we can use the information that we have in calculating those missing sides. So I'm going to use the smaller one to calculate BC. Can you see? And then after, I'm going to use the bigger right angle triangle to calculate BD. And then after, whatever I got for BD, I'm going to subtract BC from BD, and then this will give me the missing side there. So let's do it together. You'll see what I'm saying. BC is how much? BC squared will be AC squared minus AB squared, which is what? 26 squared minus 24 squared. It will give me 100. And then I do square root, square root. Now BC is how much? 10. Now, this is what I'm saying here. This portion here, it's 10. This part here, it's 10. Am I looking for that part? No, I'm looking for CD. But I'm going to use this big triangle to calculate. Now this, it will give me the whole length of BD. So let's see. BD will be AD squared minus AB. Do you all agree that I'm not looking for the hypotenuse, I'm looking for the other side. The hypotenuse I'm given as 30, for the big triangle. So I'm going to substitute that. How much is AD? AD is 30 degrees minus AB. AB becomes how much? 24 for that big triangle. So 30 squared minus 4 squared gives me 324. BD. Oh, sorry about that. Ugh, man. BD squared. Then I'm gonna do what? Square root both sides. Then I get BD as 18. Do you understand, guys? This whole thing here is 18. So if this whole thing is 18 and this portion is 18, how much will x be? X will be 18 minus 10, which is how much? 8. So the length of x will be 8, 8 units. They didn't give us the units for this one. So it's going to be 8 units together. So a nice, beautiful question that they can ask in a test or an exam. to test if you are able to recognize that X it's only this portion, this portion. Okay, let me go to application of questions. This one, let me explain this one. This one, they give you a word problem. You just need to construct, and then after constructing, you calculate the missing side. So let me try only one question here. Triangle DEF, angle E, it's 90. So I'm gonna, already I know that I have a 90 degree. So I'm gonna start constructing angle E. This is 90. And then DE is 15. So if I put D here, DE will be 15. And then DF, meaning automatically if it's DEF, this part will be F. F will be 17. Calculate the length of EF, the EF. If this is, sorry, here I don't have to put 90. I can put what? Right angle. Okay. Put a right angle. Now I've constructed it. Am I looking for the hypotenuse or the other side? I'm looking for EF. EF becomes the other side. So you're going to subtract here. And then you work it out. Is that fine, people? So far, so good. Okay, so far, so good. So far, so good. So far, so good. One more question. One more question. One more question. Okay. 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 So this one, okay, this one, let me explain this one. This one, if you're given this, we want to calculate AL, which is the hypotenuse. So this one we can fairly do. I mean, you're given this side and this side, you're going to do whatever that we've been doing, substitute into the formula to calculate how long it will take this to length, something like that. So I wanted to do this one, but I think instead, let me do this question. Let me do this one because it's a bit different from the question that we've been doing. So here, now look, let me do which question? Let me do question B. It says in triangle ABC, AB is 15. We are told that AB is 15. BC is 9. We are told BC is 9. R is, and R is 18. Am I on the correct one? No, okay, I'm here, sorry. AB is 15, BC is 9, and AC is 12. AC is 12. So what have they done? They've given us all the sides. In most cases, we are always given two sides and we are asked to calculate the other side. Am I clear, guys? We are always given something like this. Maybe we are given 12 here, we are given 15, and they say find the other side. But in this case, they've given us everything except the 90-degree angle. Okay, I don't know why is it not working. Now they give us something like this, maybe 12, 15, and 5. Just for example, they gave us all the sides, but they didn't tell us if this triangle is a right angle triangle. They say, and they give us the other values of the other triangle. They say, show that a triangle ABC is a right angle triangle. We want to prove that this is a right angle triangle. Are we together, guys? So we want to prove that the triangle they gave us is actually a right angle triangle. So what are we going to use? We're going to use the theorem of Pythagoras to prove this. How are we going to know? We're going to know if AB squared equals BC squared plus AC squared, then we know that triangle ABC is a right-angled triangle. if we can prove that this side is equal to that side. So I'm going to do them separately, and then if they give me the same answer, then I can conclude that we are dealing with a right angle triangle. So what is AB? I'm going to take AB and then square it. What is AB? 15. What is 15 squared? 225. Square that one. And then I'm going to square BC and AC and add them up together. BC plus AC squared. How much is that? 12 plus 9 gives me 144 plus 81. How much is this? Will this be? 1 plus 4 is 5. That one plus that one is 12. Carry 1, and then 1 plus 1 is 2. So can you see, guys? If I square this, I square it, it gives me the same answer when I square these two and add them up. Can you see? Now we have proven that this, the left-hand side is actually equals to the right-hand side. Therefore, I can conclude triangle ABC is a right-angled triangle because because AB squared is the same as what? BC squared plus AC squared. You need to give your conclusion. We are saying it's a right angle triangle because of this rule. They satisfy this rule. Yes. Are we together so far? I think we are. I'm going to pause it here. Pause the video. You can go through the questions again, and then you're welcome to ask if you have any question that you need. Thank you, guys. Okay.